Okay. Now, there might be some background noise. I apologize for that up front. Um, I'm sitting right underneath an air conditioner. It's Texas. It's hot. I apologize. So, this is the first in hopefully a series of these to just help sort of guide how I would approach preparing for an interview or for a programming code interview, as well as how I would actually do the programming interview in person, like what it would look like. So this is both a study aid, but it's also sort of a guide to sort of approach how you would give the interview. I'm just adapting a problem from LeetCode. I gave the link here. I'll include it in whatever notes I send with this. My goal was not to rip off LeetCode. It was just trying to grab a problem. This seems like a pretty decent one to tackle as a first stab. I do want to say that my problem description is different than the one that they gave on LeetCode. A solution to this problem would solve this problem, but the reverse is not necessarily true. Now, I'm not going to go through like all the fun ways to solve this or the complicated ways to solve this. The point is not to show off how amazing you are with bitwise operators or anything like that. The point of these interviewing problems is to get in, do it cleanly, get out. They want to ask you more questions. They want to ask you more questions about a working solution. You don't have to have the best solution. You don't have to have the perfect solution. You don't have to have the most optimized solution. If they ask you what you would do to optimize it, you would literally just start asking, when is this going to be used? In what context? What are the operating parameters? Right? In other words, you get to dive in and start asking them questions, and every answer that they give you just leads to more questions. So you get to be intelligent without even trying to necessarily how you would optimize it. Let's say how you would optimize it. In other words, if you're like, well, how big, so this is asking for an integer array as an input. How many elements could be in that integer array? How big can that array get? And whatever number they pick, you can start talking about, well, you could potentially parallelize this solution, and then you would, have to, resolve distinct entries and that kind of stuff. Like there's all sorts of things you could try to do. I don't know that this one would be parallelizable very easily. But the point is there's all sorts of things you can try to do if they start going down those sorts of rabbit holes. But the point is they want to get to that. Those are the questions they really want to ask. They just need a working solution before they can ask any of those questions. So the first barrier to entry is solve the problem. Okay? That, in other words, that is sort of the minimum goal we're trying to achieve, is just solve the problem. So how would we do that? Okay, let's look at this problem. Again, I phrased it a little bit differently than you'll find on LeetCode. I said here, given an integer array nums, so nums is our integer array, return all the distinct triplets. The triplets will be of the form nums I, nums j, nums k. So we're looking for 3 elements out of this integer array such that I doesn't equal j, I doesn't equal k, and j doesn't equal k. All this is saying is that we want different elements out of the array. You can't just take the same array element out of the array 3 times. We want nums I to be less than or equal to nums j, less than or equal to nums k. So when we present our triplet, the triplet needs to be in ascending order. It needs to go from smallest to largest. And then the last constraint is that all 3 of those elements, so nums I, nums j, nums k, the 3 elements we sucked out of that integer array, those need to add up to 0. The example that they give is this jumbled up array. So the input array is not sorted, and you'll see there are 2 negative 1s in here, and everything else is a 0, 1, 2, and then there's a -4 at the end. So you can see that there are two different triplets in here, a -1, -1, both the -1s out there, and a 2. That adds up to 0, and they're in increasing order. And then -1, 0, 1, those add up to 0 as well. They are also in increasing order, but you'll notice it didn't show up twice, even though there are two -1s. So the two -1s don't deliver two distinct triplets. The triplets would look the same. They would be -1, 0, 1 and -1, 0, 1. So we're not going to do that. Okay. So the very first thing you want to do in every single one of these problems, every single time, period. It doesn't matter what language you're in. The first thing you want to do is set up the interface. Okay, so what I mean by that is I don't mean interface in like, you know, the Java keyword. I mean, you want to have the signature of whatever it is they're asking you to do. So in this case, they're asking you to write a function. You want the signature of that function, and you want to completely define that up front out of the gate. So we're going to say public. It looks like they want an int array, or an array of arrays, right? Because we're going to turn an array of all the triplets. We'll call it threesome. I'm calling it threesome because that's the problem name from LeetCode. We want threesome of an array of nums. All right. And so this is going to return some array. There we go. Oh, did I put the 0 in the wrong place? I did. There we go. Or I didn't put enough zeros. All right. So the first thing you want to do every single time is say, this is what the operation is you're asking me to do. And the reason you want to do that every time, and you want to talk through it, you know, we're returning, we want to return all triplets. So it's going to be an array of arrays. That's what we're actually seeing here in the output. You want to make sure you absolutely state it up front as immediately as possible before you even start asking questions or anything like that about edge cases or anything like that. And the reason is because you need to let your interviewer know you understand the basic request up front. Okay? So before you start asking about how, you know, how big is the int array, or before you start asking about any of that, what you need to do is start basically illustrate you have understood the question. And so by putting the signature down just up front, you're letting everybody on the call know you understand this is what is being asked of you. Okay? The next thing I would and the point is, you can ask questions to get here. If for instance, if you're like, well, wait, return all this distinct triplets. It looks like you want the triplet to be an integer array. Is that correct? And they can say, yeah, I mean, that's what it looks like there. Sure. Do you want this to be a list of these, right? So should it instead be a list of int arrays? Is that what we're trying to go for? Oops. Was it dot import? Oh, I think there was an add all missing imports. It's so funny. It's been a long time since I did anything in it's not in Visual Studio Code for Java. So yeah, this is entertaining. All right, so the point is asking them, hey, do I have the signature right? You absolutely can do that. You can absolutely ask them what they're looking for there. They might ask you interesting questions about the decision, like, you know, do you want to do an integer array of arrays? It's like, hey, honestly, I'd probably recommend ever doing a list of an integer array. Like, this is probably not not ideal. Integer arrays as generics can get all sorts of weird. There's no constraint on the output. Like, people have to just trust that you're going to return a triplet. My normal recommendation would be to return a triplet class, but here it looks like you're trying to communicate an integer array. Is, I don't want to read into it. If someone's going to call this method, what are they expecting? Sort of the point, right? And if everything that everybody's doing everywhere else is integer array, well, that's what we're going to do. So the point is, it's okay to ask these questions. For right now, let's leave it. You know what? I already wrote it. Let's do it this way. We'll leave it as list. Okay? So, the next thing I strongly recommend, especially if they give you an example, the next thing I strongly recommend doing is setting up a test case. Now, what I also strongly recommend against is doing anything in your coding interviews that involves libraries. So, what that generally means is you're stuck using assert if you're lucky. So, for instance, I'd be willing to bet, like in the LeetCode interface, you can't use assert. You have to sort of own the ability to run things, and that's because Java in Sun in its infinite wisdom, back when Sun was a thing, Sun decided that you had to turn on the use of a keyword. There's not even that many keywords in Java, but you have to turn on the use of the keyword with a -ea, -enable assert, which is just whatever. So it's no surprise everybody grimaces at the sight of the assert keyword in Java. But we're going to use it. I've added it to my launch so that it will actually run when I hit the little run button here. But the very next thing you want to do is actually test what's happening here. So you want to write the test case. So we're going to do that right now. So we're going to assert that we're going to make a new solution 1, and then we're going to assert that sol.threesum of let's see, I can't remember. I think it's like this. Man, I've been playing with too many languages. Here, and so I should just be able to copy and paste this in. Nope. Wrong thing to copy and paste in. This thing. Copy, paste. And I think you have to do new int in front of it. Is that right? Man. Okay, hold on. Array literals. Java array literal. Oh, it's curly braces. So, will you be able to do a search during the code interview? Almost certainly not. Does it really not let you? Do you have to assign it? Oh, Java. Right. So now we get that, and we're going to do a dot equals new array list. Is it? Is there a list of? Yeah. So, yeah, and again, now we're running into the I'm going to cheat. So So what we're doing now is just trying to bypass the fact that you can't do a literal. You might be able to. It's probably worth searching for that. I'll search for that at some point. Oh, I see. Whoops. That's probably the problem. So, okay. This should have worked. Yeah, okay. Now I get it. Okay. There we go. List of new int. New int. And then these are parentheses. They need to be braces. And this needs to be open close. Or these parentheses again. Yep. Okay. There we go. Now, when we run this, we should be getting an assertion error because we're returning an empty list, and an empty list isn't going to work. Except we did not get Oh, I know what it was. I added the VMArgs and then renamed the class. So there is no app anymore. There is only solution one. There we go. And now when we run it, we get our assertion error. Assertions, in case you you can add in a string at the end and it will tell you the message that you put here after the colon. So here we go. We are now to the point where we have an input, we have an output. This input, though, is somewhat complicated. So let's start with something first that's a little easier. So in other words, the example is the thing we're building towards. I think the first thing I want to try is just if somebody gives me 3 zeros, we should be returning a list of 3 zeros. Right? Does that make sense? Oops. No. There we go. All right. Yeah, it's funny. Like, that's going to get really old really quick, but we'll keep going. So now when we run this, it's still going to fail, but it's going to fail in that first assertion arrow. So zeros should return zeros. And now we can see when we run that, that's the one that's failing. So I'm sure there are lots of ways to solve this, right? But one of the ways to solve it, of the many ways, the int arrays, yeah, that's going to be interesting. I'm curious now, do int arrays come across, like does a new int array of 000 equal a new int array of 000? My suspicion is they don't, because they need to yeah, these guys aren't going to be an object equals. So I think at this point I would ask the interviewer, just, hey, because these two arrays aren't going to be the same, can we change this thing, instead of returning an int array, can we change it to a list? And I think a lot of them are going to be like, yeah, sure, whatever, that's fine, I don't care. So what this becomes is a list of integer. Right? So in other words, you're showing something. It's probably a detail they don't care about, right? In other words, they don't want you to go write an equals solution for arrays, right? In other words, they want you to solve the problem they're asking you to solve, showing that, hey, primitives work differently and arrays work differently in Java. They're an extra kind of annoying. You know that, you recognize that, and you want to do something simpler for the sake of the interview. And honestly, it's not even necessarily for the sake of the interview. Like if you ran across this in the real world, doing something that makes the problem easier is better for everyone, usually. But in other words, being able to recognize that and ask about it, that's a very useful skill to have as a developer. Oh, oops, that's right. We were still saying that the input, though, was an integer array. So we'll stick with an integer array on the input, but the output is now going to be a list. All right. So there are several ways that we could go about approaching this problem. The first one, though, we've got this set of zeros. We want to have a list of zeros here. Because of this ordering constraint, does it make sense that our our sort of naive approach to this is almost certainly going to be order n cubed. We're going to have to loop over the array, sort of a nested thing 3 times. Now, is that the best way to do it? Probably not, but we'll talk about that later, right? Because the point is, we've got 3 variables that all have to potentially increment against each other. So this is 3 nested loops. So we're looking at an order n cubed algorithm, almost certainly. And a sort is going to be n log n, roughly. So the point is, sorting these numbers, we might as well. It's not going to affect the runtime, the order n runtime, and it'll make it much easier because then all of our, then nums I is less than or equal to nums j is the same thing as saying I is less than or equal to j. So that seems valuable. So the first thing we're going to do with this integer array that's coming in is to sort it. And we're going to do that. I want to say there's integer stream. Oh, that's probably in the version of Java. I'm not. Who knows even what version of Java I'm using? It's almost certainly tied to whatever Minecraft I ran last. Let's see. I think it might be entertaining to ask the interviewer, hey, is it okay if we switch this to a list? If they say no, it's okay. We can still just work around it. So we're just going to initialize we're just going to add them all in and then do sorted sort. What is the syntax for that? Why can't I remember? Hold on, I am curious. What Java version I'm using. It's 17. I should have all the fun stuff. Okay, hold on. What is... Why can't I remember? Single parameter, multiple parameters. Pass. Oh, colon. Good grief. Been too long. There we go. Okay. So now we have our sorted array. Just for fun, I'm going to return that list of sorted, and that should actually pass our first test case. Yep. So pass the first test case because we aren't getting zeros, should return zeros. We're getting the arrays aren't equal. So we're passing this first test case. Now, we're cheating, right? All we did was add it. We did a sort. We return list of sorted. Just to see if the sort is working the way we want it to, let's add in a test case that's going -1, 1. That should still return. Well, wait. We want it sorted. -1, 1, and we want it to return -1, 1. Let's see if that happens. Yep, we're still getting arrays. This should be simple, should return sorted. And it did return sorted. Just to double check, we'll put that in there, and it's going to tell us it's simple should return sorted because we changed it up. Cool. All right. There we go. So we have seen some, we've seen 2 test cases pass, but the problem is these test cases only have 1 element in them. So now we're just now getting to the part where we're actually going to do some work. Okay. So we want to have a list of integer, and this is going to be our, what are we calling these, triples? New array list. One way to do this, because we're talking about distinct things and now we're using lists that are going to be pre-sorted, one way to do this would be with a set and then just convert it to a list at the end. Honestly, I don't even think there's even a problem with that as a solution. Like, that seems a very reasonable thing to do. In fact, because we saw that, I'm going to just, no, I'm not going to do it, because there's also just the way to solve this, I think, the way they're wanting to. So so the next problem is we want to so we're going to iterate over the this sorted list 3 times. So int I equals 0. I is less than nums dot length I plus plus. And really, we don't want it to go to num's length. I can't ever be more than 2 away from the end, right? Because then there won't be room for j and k. So then we're going to go for int j equals I plus 1. J is less than nums dot length minus 1. J plus plus. So remember, we always want I and j and k to be different. And there's no reason to check an earlier j, because an earlier j at best will be equal to the number we're just checking, right? So because we've sorted them, they're all in order, we're going to move I along, and then j is always going to be in front of it, and k is always going to be in front of j. So k is going to equal j plus 1. K is less than nums dot length. K plus plus. All right, so now we've got our 3 numbers. I would argue that the way to think about, so we're going to have a nums I, nums j, nums k. Okay. These guys, yeah, are all, yeah, they're not used. So the first thing we're going to do is just set nums I equals I, nums j equals, oops, nums sub j. It's not equals I, it equals nums I. Nums sub, oh, and not nums sorted. Well, actually, yeah, is there a arrays? Oh, there is. Let's do that. And does this return? Sorts the array into ascending numerical order. Whoops. What does it return? Does it return a new array? So obnoxious. Usually they will tell you if it returns the same array or not. Ugh. All right, I'm going to assume that this thing returns an array. Oh, no, no, no. Yeah, it's void. Yeah, it obviously, yeah, okay, it's void. It sorts it in place. So now we don't have to do all this sorted mess. That all goes away. No, I wanted to do that. Let's see. Yeah, so this is now, because it's sorted in place, so this is now num sub I, num sub j, num sub k. And you'll see why we're doing this assignment. It may not make total sense right now. I am cheating a little bit and planning ahead, but the point is, we now know, we now have these three numbers. So if num sub I plus nums sub j plus nums sub k equals 0, then we want to triples dot add list of nums I, nums j, nums k. Okay, and then we're going to return triples. Okay, so super quick. If this makes sense, if it works, the two threesomes that we already had, so the zeros and the simple sorted, should both still work. Let's double check that. Yep, and we still got two arrays aren't equal. So those two are still working. So our new little algorithm here that basically just did exactly what the problem said. Seems to work. The problem is it's not working because of this arrays aren't equal. So in fact, instead of printing out arrays aren't equal, let's see what what this result is. So we're going to pull this out. Result equals that list of integer. Result equals that, or we want to print out the toString for result. Let's see. I can't remember how nice list gets. Yeah, there we go. So, and again, we're seeing we have these duplicates that we didn't want to deal with. Right? So now it's just a matter of trimming out the duplicates. Well, so my argument is on duplicates. Think about what happens if we bump j to the next index, but the next index's value is the same value as the previous value for j, or the previous index. Right? So if two elements in a row are the same number, then whatever happens next is going to be the same number. Whatever k did, if it actually finds an answer, it's going to be the same thing. So we want to keep going if nums j equals the same thing that it equaled before, if that makes sense. Now, my claim then is to make this work, we want to initialize nums I every time or nums I, nums j, and nums k every time we go through the iteration. We want to initialize them to the a value that couldn't happen, right? So a value that's smaller. That way, every time we come through the loops, the first thing we compare it to is obviously not the value we're comparing it to, right? But we know the smallest value in the list is num sub 0. So if we just look at num sub 0 and subtract 1 off of it, we're now a smaller value than you would ever find in the nums array. And since it's a smaller value than we would ever find in the nums array, it won't be equal to whatever value we find in the nums array. And so if we have a test in here that says if nums j equals nums sub j, continue. Right? And so the problem that we're seeing, again, is that nums j may not have been initialized. We need to initialize nums j to num sub 0 minus 1. Now, you'll need to ask, if this is an assumption you're going to make, you'll need to ask, hey, what's the smallest value we can have in num 0? Or in nums, right? How small of a value can we have? Because if it's min int, you can't subtract 1 from min int and get to something that makes sense, right? So, it's you'd have to ask this question. It turns out that in the problem in leak code, the minimum is minus 10 to the 5th, and so yeah, you got lots of room to subtract 1. So that's what we would do for num sub j. Num sub I, we'll initialize that right here too. Num sub 0 minus 1. And then num sub k we'll initialize here. Nums k equals nums 0 minus 1. So then we'll copy this up here, and this will be nums I. For these brief continues, I do like to format them this way. Oh, but Java doesn't, so it'll format it that way. Now, why am I not doing it here? Well, if I and j are different, the only way for k, if the element in I and the element in j are different than anything we've seen before, then we know we're looking at a different triple. It doesn't matter what the value of k is. And so I'm just leaving this value of k running around, but it means I don't have to do this if. That if would just be wasted time here. If you want to add it, it's fine. It won't screw anything up. You're totally okay with adding it. But now we'll run it, and everything works, and we have passed. Now again, the goal of getting to this point is for them to start asking questions. Do you think this is the most efficient? Oh, no. But it's not the sort's fault. The sort is a lower complexity than the for loops. We're doing 3 nested for loops. Is this the best we could do? Probably not. My suspicion is you could probably get it down to like an n squared log n, so that instead of, because does it make sense? We know exactly the number we need to find here, right? We know exactly what we're looking for. We know it's negative. We need to find whether or not this list contains negative I plus j. Right? So whatever these two summed up to, we need to know it's negative. When we compute that sum, that I plus j, if it's positive, if the nums I plus nums j is positive, there's no hope. Right? Because if it's positive, that means j was at least positive, and that means adding in whatever k is going to be bigger than j. We might as well throw it away. Right? We need a negative sum on I and j. So we could have a check here that's if nums I is plus nums j is greater than 0, then we return triplets. Some people don't like doing returns in the middle here. That's fine. If you don't like doing it, totally cool. Don't have any problem with that. Oh, triples. I called it triples. If you don't like having returns in the middle, doesn't bother me. Just do break with a label. And then that'll kick it out of the top for loop and return the triples that way. I think this is less clear than a return in the middle. Other people disagree. So hopefully this makes sense, right? Like why we can break here. My suspicion is that this will also change the complexity pretty quickly as well. There are lots of other checks you could add, like if nums sub nums dot length -1 is less than 0, return new or list. I think there was an empty. It's just list of. Yeah. Right? So in other words, if the biggest element is negative, we can never add up 3 things and get 0. So we might as well just bail on that early. In fact, you could add that before the sort and save yourself a sort. So the point is there's lots of these sort of like breaks we could add in where, hey, another break we could add is add up the top 2 elements, the 2 biggest elements. And while I is less than, if I is more negative than that element, you might as well just move along, right? There's nothing to do. The other thing would be, oh, no, wait, this has to happen after the sort for it to play nice. But it's also worth breaking if nums sub 0 is greater than 0. Right? So again, my point is there's lots of ways to say, hey, we can do different ways of like short circuiting. There are different kind of constraints on the array where there are ways to sort of get out of doing any processing, if any of that mattered. But that's when you start asking, hey, how big is this n array really going to be? How often are we calculating this method? Because if the point is, if it's not happening that often, then what you really want to do is have the simplest method here where anyone who can come in can look at it and see exactly what's happening. And so my claim would be, if you want to make this where it's the simplest thing anyone could walk in and just, oh, of course, that's exactly what's happening, then my claim is you don't want a lot of this complexity, right? What we really want is to simply say, if nums I plus nums j plus nums k equals 0, we want to return that, right? This is the thing we want to do. And so then the way that you can make this happen is to turn this into a set, whatever your favorite hash set is, or favorite set is. Add all missing imports. And then what we're going to do is just turn this back into oh, no, right. New array list of triples. Right? If you pass in a collection, if you pass in any collection, it'll convert that. It'll suck the elements out of that and put it into a list. I think there's actually, I think there are nicer things. I think there's just a list of, yeah, a copy of. And that may actually be a little faster. My suspicion is that this is lazy or something along those lines. Right. Yeah, cool. So my claim is, this is the thing you want. So let's just double check that this is playing still by the rules. And it is. My claim is you want the simplest thing that is readable, does exactly what you want. All of those things about checking whether or not the array has happened before or the element has happened before, are we over our limits or anything like that, my claim is those need to happen because you've actually measured this and said, hey, for the use case that's happening, that 80% of the time things come in and the lowest number is positive. So this triple sum is never happening, right? You need to be able to measure it. You need to be able to benchmark it. You need to be able to profile it. And you need to be able to make sure that the change you introduced had a measurable impact on performance. Without being able to measure all that stuff, just adding in those random if statements just complicates the function and doesn't actually give you any meaningful... and it clutters what this method is trying to achieve. It's just making it harder to maintain in the long run. So that's my claim of how you should approach a lot of these problems. Being able to simply defend a solution. And again, keep in mind, it's not that it's right? What you want to do is be able to say what I said, right? You want the simplest possible thing that does exactly what it says it does and no more. That makes everything better. So we switched to having a list of lists because a list of lists let us do exactly what we want. I would actually argue the right way to do this is collection that this is really what folks want. And then you can just do this and everybody's happy. Okay. There. Does this still work? No, zeros should return zeros. It's because this is a set of, and now, there we go. So, hopefully this was helpful and instructive and gave you a little bit of context around how you would go around solving this. Now, again, my Java is super rusty. I'm embarrassed at some of the things I had to. I could not remember colon for the well, and couldn't remember array literals. Not remembering those things during an interview makes it very clear that you have not been programming for a while. And spoiler, I have not been programming for a while. Certainly not in Java. So anyway, yeah, hopefully this was helpful. Happy to do more of these if it was. I know you prefer 5-minute videos and not hour-long videos, but well, it's interview prep. That's how it works. So anyway, hope this was helpful, man, and happy to do more. I'll talk to you later.